Hello community, it is so great that you are back. Today we'll look at the latest technology of RAG. We will have a very short excursion, RAG, GraphRAG, LightRAG and the latest development, PathRAG. I will explain you how it works and give you the code for this. So you know that the classical RAG, Retrieval Augmented Generation, we have a lot of techniques to make RAG work. And just here from Reviate, those are the advanced RAG techniques that we know today. We start with index optimization, fixed size chunking, recursive chunking, document-based chunking, semantic chunking. We have the pre-retrieval optimization, the retrieval optimization itself, then the post-retrieval optimization, all the different methods. And you know, it is not really working perfectly. So therefore, we developed graph-based RAG system and they work much better. However, if we look at two graph-based RAG system, the graph and the LightRAG here today in this video, we will discover they are also able to be improved upon, because they retrieve some excessively broad subgraphs, they have noisy prompts, we have increased computational cost because of this, and ultimately we have a suboptimal LLM performance. And then we talk about the solution, because GraphRAG evolved. The very last technological state is PathRAG, published just days ago. They set out to solve all those limitations. So PathRAG and the rise of relational reasoning here for the RAG system is our topic. Let's start here. Let's open this video. And of course, if you're new to GraphRAG, what is the most important paper? February 19, 2025, version 2 here. GraphRAG here, approach from query-focused summarization. GraphRAG is simply the author tell us, hey, RAG fails on global questions that are directed at the entire text corpus, such as, what are the main themes in this dataset? RAG cannot tell you this, so therefore they developed GraphRAG. GraphRAG uses all the information from the node and the edges within certain communities. And those communities are here the solution here, because they build now here a graph index in two stages. First step, derive an entity knowledge graph from this source document to your text database, for example. And then second, pre-generate community summaries for all groups, for all thematic clusters of closely related entities. So, given a question, each community summary, each cluster summary is now used to generate here a partial response. Maybe the query relates to multiple clusters in your knowledge base, before all partial responses are summarized for the final response for the user. Very simple visualization. We have here all the text documents in the text database. We have the extraction and all the chunking going on. Then we have the text chunks, and then we have the summarization. We have the entity and relationship, interdomain tailored summarization, and we build here our first knowledge graph. This is done in indexing time. So when we have then the query time, we have communities in the knowledge graph. So we evaluate now relevant communities to the query. We have graph communities, domain-tailored summarization are already waiting for us. So we do have the community summaries ready. Then we have the query-focused summarization. We have partial community answers for multiple topic clusters. And then we just have a global answer that is the fusion of all the sub-answers. It works great. And I can tell you GraphRAG shows substantial improvements over the classical vector RAG baseline, both for all the different factors. You know this. LightRAG, the second methodology. November 7, 2024, Beijing University. Really interesting. It incorporates now the graph structures into text indexing and the retrieval process. And this text indexing became really important for this. Let's have a look at this. We have here our text, our human readable text into your text database or whatever. And here's an example by them. They have beekeepers, and they explain a beekeeper is an individual who produces honey. And then we have other links to this beekeeper. So the graph-based text indexing now here is relatively simple because we have three steps: deduplication, LLM profiling, a beekeeper. Beekeeper is a person who, yeah, great. And then the entity and the relation extraction from our text here. And this is simple. We have the nodes, beekeeper and bees, and observe we have a simple link entity. We build now an index graph that has all this information, And we will use this index graph, could be a rather complex index graph, for the retrieval process itself for RAG. And now we have a lot of additional information in our node and edges. We have then high-level keys, low-level keys, and we have a dual-level retrieval paradigm with entities, relationship, and context. This is all beautiful, but the most important factor here is those index graph for the retrieval. Here we have all the important information that we need for a graph indexing. Extract various entities, the name, the date, the location, all the events, and we record all the relationships between them. This information collected through the process will be used here to create here a comprehensive knowledge graph that highlights now all the connections and insights across the entire collection of all the documents. So we built this up beautifully, and this is a very active community. If we go here to their GitHub, LightRAG, you see just 6 hours ago or 5 hours ago. So there's really some dynamic momentum here. MIT license, more than 12,000 stars here. Great, have a look at this. What I particularly like is here the graph visualization code. It is so easy. You use Network X here, and you can generate your GraphML file here. Your network, you can have even some more advanced three-dimensional visualizations, interactive. So you immediately see here all the connectivity and the important structures in the index graph. Now you remember we have seen a similar structure, and this is here my video about 9 DeepSeek agents that Augmented build up here a knowledge graph. And yes, of course, this is also a knowledge graph. So we also have a summarization agent, an entity extraction agent, a relationship extraction agent, even multiple if we have multiple specialized domains. We have a schema alignment agent because we have now new knowledge that should fit into an already built knowledge graph. We have a conflict resolution agent or multiple. We have evaluator agents. So you are familiar with this. Of course, it's a knowledge graph. But this is also now a knowledge graph, but this indexing graph is now something special. And we will build on this on the development of GraphRAG. So it is really important that you are 100% sure you understand the indexing graph. Graph structure indexes here the text database or whatever you have, your private corporate documentation. Think about it if you compare it with the classical index here. A traditional RAG system. Now you have textbook, you have pages, you have paragraphs, and you index each page or index each paragraph by keywords. And then if you search for the word photosynthesis or whatever, you get all the pages that mention this particular technical term. We go now the next step of an indexing graph for the RAG, and we build here kind of a concept map of the textbook. So our nodes and edges are clear, but new is now the textual chunks that we take care of. Those are now our valuable additional elements that we're going to use. Nodes are clear, no? Nodes like photosynthesis, chlorophyll, sunlight. Edges give us the relationship. Photosynthesis requires sunlight. But the textual chunks, those are concepts and relationship, would be linked back to the relevant sentences and paragraph in the textbook that explain them. So let's come here to the spark of genius, and to take the next step, it was important that the creator who also built your LightRAG, the same scientist, found out here, hey, we can argue now, analyzing those systems, that the information considered in the previous graph-based RAG methods here, these two, are often redundant. And this redundancy of the data, of the information, of the knowledge in our graphs can introduce noise into the system. It will degrade the model performance, and it will increase the token consumption for nothing. So now the researcher that built LightRAG, for example, said, you know what? Moreover, we found out that both those methods adopt here a flat structure to organize the retrieved information in the prompts. So we are just directly concatenating here the textual information of all the retrieved nodes and edges, and this leads here to a suboptimal logicality and a coherence, and we can do better. So the core new idea was now to overcome all those limitations of their last model. So this new, if you want, evolution step here of the graph-based RAG will now reduce noise, reduce the token consumption, and improve the quality of the answer given. If you want to see the detail, the inner working, how this works, the next 5 minutes are for you. If you say, I don't want to understand how it works, skip ahead to the code section. The PathRAG methodology starts simply by identifying now the keywords in the user query, in my human query. And the system then uses here my keywords to search now within the indexing graph. So yes, we have to build an indexing graph from our text database or whatever we have, and the retrieve nodes that are considered relevant based on these keywords. And this preliminary step narrows now down the search base because we define our starting points. And then we have a flow-based pruning algorithm with the specific distance awareness. So if we flow now through our knowledge graph, we start from the retrieved nodes, we filter out the paths that are less important, that are less relevant, and we are distance aware. We have the complete knowledge, the mathematical knowledge of graph theory. So whatever specific parameter of graph theory you apply, you can prioritize shorter paths or paths that are more directly connected. And this means that hopefully they are more semantically correlated and less noisy. Plus, we can assign here a numerical value and a reliability score to each path, and this will allow us to rank those pathways. And then PathRAG will now fetch this additional, very valuable textual chunks that are associated with each node and edge along the path. And we have here the importance again of this index graph underlined. We have concatenation of the textual chunks in the order they appear in the graph, node edge, and this concatenated text becomes now a textual relational path. And this is a human-readable textual representation of the path and its associated information that is now so valuable. And here, now for the LLM, this becomes now an easy task. So you see, PathRAG is a methodology which effectively retrieves here key relational paths from an indexing graph we built from a text database with a flow-based pruning methodology, and this effectively generates your answers with a path-based LLM prompting optimization. Isn't this beautiful? Okay, so let's come to the hard facts now. We have here February 18, 2025, PathRAG here, this RAG generation with relational paths. And the authors here are again the Beijing University, University of Hong Kong, and Northeastern University. So remember, those are also the authors from our other GraphRAG systems. So this is here the natural evolution. And now these relational pathways are so important. Let's have a look at this in detail. Let's give you an example. We have plants. Plants are infested by aphids, and aphids are fed on by the ladybugs. So this path represents now the relational chain. Paths are infested by aphids, and aphids are fed on by ladybugs. And this path shows here a relationship between the plants and the ladybugs, mediated through the aphids in the context of the pest control. So you see, we already have a semantic environment defined. And in this PathRAG methodology, both node and edges have, as I told you, these beautiful associated textual chunks. So this relational path is not just now a sequence of node and edges in an abstract graph, but it implicitly now includes the textual description of all those entities and all those relationships along the way. And when the PathRAG then converts those to a textual relational path, it's making this textual information explicit for the LLM to reason on. This is here the original visualization by the authors from Beijing University. I found it not so helpful, but I love this visualization here because it gives us here a complete overview of the methodology. So we start with a human query, and my query is, what organic methods have been effective in reducing here pest populations? And from this query, the system now extracts here what it thinks are the most important keywords, organic methods for pest populations. Then we have a database. Now this is our external knowledge, new knowledge, updated knowledge, more complex knowledge, whatever. And now we index this database here and we generate now an indexing graph, kind of a knowledge graph, but a very specific knowledge graph for this particular database. So you see there's a dynamic factor and an update factor, but more about this later. Now what happens, we have here our keywords and we have the indexing graph. And now with a node retrieval augmentation, we build now our first graph. So we have now, and you see here coded in orange and this coded in, let's say, green. We have now additional semantic information like ladybugs feed aphids, aphids feed parasitic wasps, and we build here our graph. And now what we do, it is simple. Look, we have now our node pairs like ladybugs and aphids, beautiful. And we just have now a reliability score and distance score. We have now graph-based indicator we can calculate from the classical mathematics of graph theory. And now for each edge in a particular configuration of our knowledge node and edges, we have now scores, and these scores can now be ranked. So this means our paths are now ranked based on the scores. So we have now the top path from ladybug to aphids, from ladybug parasitic wasp to aphids, from, yes, you get the idea. And then we have here, given here the specific parameter of the reliability score, we have now a ranking of the top path. We invert this here for the path-based prompting for answer generation because you know the LLM is most sensitive at the end of its attention window. And this is it. This is the complete methodology. And you might say, great. And I would also say, great, if I would not have one main question remaining. And this is it. How the hell do we arrive at this graph representation? And I said, please don't tell me that we again have to build like a vector space like in PathRAG, like in the classical RAG that we did overcome years ago. Now I have to tell you, yes, the authors of the study told us here, based on the extracted query keywords here, our two here, a dense vector matching is employed to retrieve here related nodes in the indexing graph. In this dense vector matching, the relevance between a keyword and a node is calculated by the similarity in the semantic embedding space. So it is again a vector space, and we use here the cosine similarity. So we are back here to go from the keyword in the indexing graph and find semantically close related tasks or clusters or elements. The whole system is beautiful except for this, that we have to go back and build a vector space from a classical RAG system. My goodness. But you know what? There are alternatives, but more about them later. Let's go with this study by Beijing University. Now, Beijing University said, hey, we want to compare now for a lot of data. If we have one question, what are the derived features? Yes. And now we built a LightRAG, so let's have the response by the LightRAG, by this GraphRAG system. And then we have the response by the PathRAG system. And you know what? We use an LLM as a judge. So go with whatever you like. And they have now here in multiple, let's say, dimension, comprehensiveness, diversity, logicality, coherence, and relevant the answer by the LLM. The LLM compares those two textual responses and tells us, answer 1 lists only 8 features. Answer 1 only primarily focuses here on rather common methods without exploring advanced techniques. Answer 1 has less cohesive reasoning structure. Answer 1 is less fluid in its transition, so you get it. PathRAG is outperforming LightRAG. So the system works. Isn't this beautiful? Now, they ran all the evaluation tests and ablation studies and whatever, and they have now the final result. PathRAG, this latest evolution in the GraphRAG system, consistently outperforms here the baselines across all evaluation dimensions on all data sets. And here you have the data for you to check yourself. Those are the 5 dimensions of the evaluation. And then we have here the data sets, agriculture, legal history, CS biology in a mix. So if you run all the tests, beautiful. PathRAG is great. Let's look at the code. We have here beautiful GitHub. If you go to PathRAG Pi and whatever else you need, I just had a look here at this particular Python file. And yeah, Unfortunately, here you see it now in detail. Yes, we do need here a vector database storage. My goodness. At least we have also open source methodologies. You don't have to pay for a commercial solution. You can build your own if you want open source solution. But I would say such a beautiful implementation. But again, coming close to what are semantically close by terms here, we have to fall back to the old vector database. Now, of course, as a subscriber of my channel, you know that there's a beautiful alternative. I already did a video here on RAG's intelligent upgrade, the agentic roar from Oxford University. Yeah, but this is a video in itself. Now, at the end of this video, there is another point that is important for me. And this is about a new study, RAG in medicine. And I thought, hey, should I post this here on my posts on my YouTube channel, or should I integrate it in a video? February 18, 2025, we have MIT, Stanford University, and Duke University. And they publish here kind of a warning about retrieval augmented generation, our RAG system in medical AI. They tell us retrieval augmented systems can be dangerous medical communicators. I recommend that you read this study if you're interested in anything that is related to medicine, how humans use AI for their own medical purposes. And yeah, unfortunately, I understand that some people who might not have access to a human doctor, they might rely here on medical AI systems. But there's a strong word of warning from MIT, Stanford, and Duke about RAG system. They tell us the current retrieval augmented services often use cited sources to generate narrowly accurate but pragmatically highly misleading responses. Now, clear, I'm not an MD, I'm not a medical doctor, I'm a theoretical physicist, so I don't know here the test that they show us here in this study, if this is really the medical complexity, good or bad or better or worse. I have to trust here the judgment in medicine, MIT, Stanford, and Duke. But let's say we do this, so that we come to the conclusion that our RAG-based system that we apply currently reinforces here the patient presuppositions, decontextualize here important facts relative to the source material, RAG-based system generating misleading sentences for our human patients, produce results without an intuitive and pragmatic understanding of downstream consequences. And I thought this is a real strong warning issued here by those universities. And I just want to make you aware, if you use a RAG system in medicine, there is still a lot of research to be done. Now, I looked at the data to get a feeling, but unfortunately, this is a domain knowledge I don't have. Why is liver transplant dangerous or kidney transplant? And they went to Perplexity to get all the answers, but I cannot evaluate these answers. Sorry, in this particular video, this medical knowledge, I cannot provide here a personal reflection on the quality of those data set. I simply have to trust those universities. And they tell us here retrieval augmented system can be dangerous medical communicators, and current RAG-based responses to health information queries have the potential to mislead and reinforce biases due to numerous intersecting pragmatic communication fallacies. Failures to interpret the queries, misleading representation of sources, misleading language in generating responses, and this seems to be a work that we have to improve significantly. Now I think if we only find this in medicine, because medicine is so immediately important for humans, no? And we find out that the RAG system do not work there, what about the performance of RAG system in finance? What about the performance of RAG system in education? So I have not such a positive feeling reading this particular paper here about RAG system in science. Yeah, for example, here, if they go here with specific medical terms and they say, hey, why is the procedure dangerous or why is the procedure safe? I can't tell you if to evaluate those answers and really tell you that the deductions, the results that they presented is valid. But if you are an MD, please have a look at the study. And I would highly be interested in a professional response here, given the details of this study. But I think it's great that MIT, Stanford, and Duke have a look at these topics. And they tell us, hey, those RAG augmented generations are not ready in medicine for, let's say, the normal person like me. And yes, I have to tell you, me too, I thought about when I had some medical condition to go and ask here AI system. But then I decided, no, I know how this system works, so I do prefer to go to a doctor. I had to wait, but well, yeah, this will be a topic for some other videos, but currently we have this strong warning here. They can be dangerous medical communicators. And there you have it. This is the video of today. We had a look at RAG, at GraphRAG, the evolution into LightRAG, and then the latest technology for you with code implementation, PathRAG. I think it's absolutely fascinating how RAG systems now develop, and maybe we can increase here the performance of RAG system in one of my next videos, because yes, there's even a new development in the pure mathematical knowledge graph area. If you want to subscribe, you will be notified immediately.